And the things that I didn't know about it, why, it was like, for instance, sodium and potassium, voltage gated channels, where effectively, why does the action potential do first sodium and then potassium? Because potassium is less sensitive to the action potential change than sodium. So sodium goes first. They're in such close proximity, it doesn't matter when that transition occurs. And then as sodium finally spends itself, then the potassium become activated. And it goes into a little bit about absolute and relative refractory periods. Absolute refractory periods means because you're effectively, you're way, as long as you're past threshold, effectively you're in an absolute refractory period. Yes, it's helped by those inactivation gates. Yeah, I mean, there's different things that play a role into it. The relatively refractory period is more about that overshoot as potassium is escaping, okay, and really almost overcorrecting in the nerve, actually temporarily hyperpolarizing it, bringing it below resting membrane potential until the potassium comes back into the cell, where the abundance of potassium, where the gradient is such that it comes back into the cell, and the rather sodium is reattracted in, and sodium potassium pumps do their thing, etc., etc. That's the relative refractory period. So I think it did a good job explaining with regard to that and why it's propagated in that way, and the fact that everything else is really in the nervous system, unlike the motor end plate, where everything is tending toward an action potential. Now we have basically either agents, and it didn't go into. It's funny, it didn't go into the neurotransmitters. I thought I would maybe include something about that. I know we covered it. Did you cover neurotransmitters yet to any extent in other maybe acetylcholine and salimelech?
No, not much
No.
beyond acetylcholine.
Yeah, acetylcholine would be the one that you, and to understand, I thought maybe I should include that, or at least supply you, maybe just print something up from my notes that we can utilize from that going forward. And again, this is, like I said, this will be, I'm sure that the nervous system will be one of the things that'll be on the final that are there. So, and again, we talk about with the nervous system, we have things that are depolarizing agents, more likely to fire, and hyperpolarizing agents less likely to fire. And they elaborate pretty nicely about this. Literally hundreds, if not thousands, of communications between nerves, making that determine what to effectively what to ignore, what to react to. Very, very interesting. And I want to go over the questions. We'll do that afterwards. And that first set of questions that were there, we look at that. And then subsequently, now communication between neurons in the synapses, talks about the synapse. We know about the calcium voltage gated channels and the role they play. Okay. That's there. And all the different ways. And it was interesting. All they said about neurotransmitters, 50 types of neurotransmitters have been identified. Different neurotransmitters are characteristic of different parts of the nervous system. Okay. And so you do need to have a certain degree of familiarity, particularly with the ones based on the questions that they have in this chapter of the autonomic nervous system, which is mostly acetylcholine, neither epinephrine or norepinephrine. So you're pretty good shape on that. I would, if I think about that, I'll make sure I get that to you. The ones that are usually excitatory, the ones that are usually inhibitory. I think that's important in case, because that would come in a passage. The role of like the G proteins and how they work, etc. The glial cells is very straightforward. You can read that as easily as I can read that to you. Understanding myelin, I think, is important. They made a very interesting point about that, is that because myelin, this fatty substance that surrounds so many nerves, it's a fatty substance that's there. And effectively, it would be very resistant to electrical current. So what we have to utilize effectively is charged particles in areas where charged particles can be moved. And they're different. They're by definition larger than if we're just thinking about electrical current. And inherently that makes it slower. So part, and that's why when we see increased amounts of myelin, interestingly makes it effectively, I'm trying to think of the way they phrase that. On the myelination. So they look at the 6 different types of glial cells that are there. I'm trying to find that. I should have underlined it when I was looking at it. Why myelin was so effective, and I think I'll buzz through it and find out. You can see that. Give me a minute just to look through this relevant refractory period during this part. I wonder if it was an aside thing or not. Myelin this is the non-conductive insulator and thus reduces the capacitance of the axon, which encourages ion flow just as the increased resistance does. Okay. Those of Ranvier we'll go over again. Saltatory conduction. Where is that piece? Oh heavens! I'm gonna have to find that and basically make sure I note that for you separately. So I'm just looking through this, and then there's some questions here at the end which we should be able to answer as is that are there. So bless you. Okay, moving on. Oh, thanks. Didn't need that. So this is again my basic little construct of the brain. So when we were looking at the structures of the brain anatomically, and we did this in anatomy a while ago, effectively from higher order functioning to lower order functioning. The exam crackers basically divided it into 2 areas. And so what they were talking about is effectively that we drew the cutoff here, ignoring thalamus, hypothalamus, and epithalamus, and it's basically what's associated with the limbic system, which is the emotional system. The higher order functioning part of the brain, cerebral cortex, basal ganglia, and the diencephalon, which is what that represents, thalamus, hypothalamus. And they don't even acknowledge the epithalamus, which is the pineal gland, considering it more endocrine than nervous system. And I'm fine with that. Cerebellum, midbrain, and the pons, and the medulla would all be basic functioning. So we think of higher order functioning and lower order functioning. And so you just have to have a basic idea of what each of those areas do. And then finally, really it's not a whole lot of functioning spinal cord body. Basically it's receiving signals and sending signals. About the only thing that the spinal cord kind of does on its own is certain reflex activities. Like for instance, it's like when I flex on this side, I extend on the other side. You have like a contralateral extension phenomenon. So if I stepped on something and I flex this, but in order for me to stand, I have to extend this. So there's certain reflexes that are part of what goes on that we have that are effectively within the spinal cord. And in general, reflexes by definition are protective in nature. And they talk about the nature of the reflex arc. So the spinal cord really doesn't have any processing or higher order function whatsoever. It's there. And so if you look at it working your way up or working your way down, I always go from the top down. Cognitive, being able to, the highest order of function that makes our brain so unique has been, and it talks about that a little bit in that, in all those, in all the discussion that they have there, is as we have evolved and advanced, the folding, having this brain that's contained within a skull, folding and unfolding and creating all those wonderful sulci and gyri. So we have large amounts of information and large amount of processing that we can do in a relatively small space. And what the divisions are, so you have 4 basic lobes. The insula is a primitive lobe that is sort of located centrally. Most primitive things I find in the brain / spinal cord are located deep within, sort of centrally placed. As things moved out more peripherally, they're more advanced. And remember, sort of that basic construct that's there. We have a central canal of some type, fluid in the central portion. Okay? So you have some central fluid that's there. So in the spinal cord, and all of these areas are the same. You have a certain amount of gray matter that's there. What the difference is, gray matter is basically synapses, cell bodies, non-myelinated nerves. All of those are typically in close proximity to wherever that central fluid area is. And then white matter in fair abundance, usually there's more white than gray. Because really those are all the communicating channels and they're all myelinated. By white matter, by definition, means myelin. And then only in the highest functioning areas you have external to that additional gray matter, and we have a name for that gray matter, cortex. Cortex is by far and away the highest functioning. You only have cortex in that regard. Again, cortex and medulla are generic terms. Cortex is the outside, medulla is the interior. When we talk about the adrenal cortex and the adrenal medulla, the kidney, we talk about the cortical and the medullary structures that are there. When we're looking at it here, it's a little bit different. Okay. Here, the gray matter or cortex is really the area of the highest functioning, and we only have that in those 4 major cerebral lobes. I have up there frontal, parietal, occipital, temporal. Okay, and the cerebellum. Cerebellum is interesting. To me, the cerebellum is this higher order functioning of, dare I say, non-cognitive things. It's almost so it's processing the information, recalling it, collecting it. And remember what the cerebellum does. It's got a very, very specific definition. Cerebellum, I know I'm jumping around a bit, but I think really it's underestimated. We call it ipsilateral. Remember the 2 different terms. When you see the term contralateral, opposite side. Right side of my brain is telling my left hand what to do, left side of my brain is telling my right hand what to do. Okay. Ipsilateral means same size. So cerebellum is basic responsibility, ipsilateral motor coordination. You want to call it motor memory? How about that? Processing signals. That's where all those wonderful proprioceptors, remember that's a specialized receptor that we don't give a lot of credit to, but they're always there. In fact, yeah, hey, you all know, I'll wager that you're all sitting. Maybe not all. I've got students in some of my nursing classes here. I'm sure they don't. They're sleeping. Where all the students sleep, where they always slept in class. Groucho Marx, 1932, of course. Great line in that. See this one. If you're not familiar with the Marx Brothers, they were hysterical back in the 20s and 30s and even into 40s. He's the one troublemaker who never spoke, Harpo Marx. You should look him up in his life. He said, comes in here, he goes, "You got to stop burning the candle at both ends." And now he always wore this big, like, raincoat that had 6,000 different things in it. Out of it, he came a candle burning at both ends. Hysterical. Moving on. Nevertheless, so proprioceptors tell you where you are in time space. So I know I'm standing up. I know I'm holding this marker. I know I can tell I'm holding a marker because the way I look at it, I can feel it. That's what proprioceptors do. They give you an idea. I mean, it's all communicating information. So what I'm doing, or walking around doing the silly things I try to do to sort of, reinforce points, what happens is all that material is being processed and recalled and recollected. Future reference. So I don't have to think about walking over here, where I'm going to put my feet, where I'm going to have my arms this way. Any of that stuff. That's motor memory. That's really the role. So the cerebellum is probably keeping order for all these, if you will, involuntary things that are responsible for that. So first, going back to the cerebral cortices, take them in sort of backwards order, if you will. The occipital lobe dedicated to one thing, really, visual processing. Our ability to see something before we can see it and recall it. The occipital lobe is taking those signals, size, shape, silhouette, basically be able to identify, we can identify what we can create the picture. Okay? So it's processing. It's like taking that digital image and processing it into something that hopefully we can recall. The same thing with the temporal lobe, mostly taking auditory sounds, noises, into some type of pattern that we are going to eventually be able to recall, process, response, the same as the occipital lobe. The temporal lobe also incorporates balance. The temporal lobe probably incorporates certain aspects of smell and taste, though they're so primitive that the insula is probably where they're found mostly. When we talk about the parietal lobe, that's sensation. Not of those special senses, general sensation. It's like, I can feel the amount of padding on the floor on this, it's pretty much standard, sitting on a concrete slab carpet. Right? You know what this is, rather than a plush carpet that you can walk around barefoot. It's the same way you would feel if you were walking around barefoot and the cat or the dog leaves me a little surprise, which they're wont to do. Same thing as, I say, oh, I dropped something. I say, don't worry, I know how to find it. Just walk barefoot, you're going to step on it. But, effectively, that's what parietal lobe is, general sensation. And remember that mapping thing, that thing called a homunculus, where it basically maps it out. So we know even exactly where it's going to be. And you have to know something about that basic anatomy as well. To understand, if you go back and look at the anatomy slides, and I'll put them on here. But remember, there's a divide. So the parietal lobe basically is where we sense things and do a certain amount of interpretation of those senses. So think of it this way. It's almost as though it's processing material, even to some extent. Sight images, sound images, other kinds of sensations may actually undergo. Remember that the white matter is divided into 3 tracks. You have ones that cross over, commissural fibers. You have projection fibers that go up and down. And when the fibers on the same side, this is where the association fibers, which there's so many, really play a big role. And what they do with the association fibers, they're able to basically take some of that processing information, okay, and you're going to get a certain amount of reaction, let's say, from the sensation that might be associated with that sight or that sound. And eventually, it's sent by those association fibers or whatever side of the brain is being perceived in to the frontal lobe, and the frontal lobe is going to take care of it, basically interpret it, try to understand it, try to interpret it with whatever order that comes in, formulate a response if necessary, and enact that response in some way, shape, or form to affect the response, whether it's a verbal response, whether it's a positional response, whether it's some kind of a change, all of those things. That's kind of the way it does. And then we have other parts of that frontal lobe. So the frontal lobe is everything with regard to language, interpretation, calculation. And then there's other areas, remember that prefrontal cortex that's so important, that plays a role in us, how should I say it? There's the emotional content to that. So, we do things Understand, did that image provoke something in us that had a certain memory, be it positive or adverse? Did that smell, it's the same thing with a smell or a sound. I mean, am I listening to a baby crying, in our house, if I hear, there's a dog barking at something, what's going on? So there's different things that will occur, or the dog running down to the door when I'm trying to watch the ball game. You just went out. Don't go out again. Hold it. The dog, however, frequently will listen to it. So, and you can look through all, and they summarize all of these things without me having to take an inordinately large amount of time. But we look at those things, and again, the dominant aspects, they talk a little bit about that. These coming on left and right brain. I don't know how accurate that is. There was something in that passage, I don't recall it. I read it this morning. I probably should have remembered it. It's going through all the stuff I'm talking about. Doesn't simply receive information, which is cerebrum. And it also influences our experience. First, cerebrum processes, interprets. And some of this goes into the psychology and sociology aspect, which I can't comment on. But I understand there's an overlap here when we're looking at the parts of the brain and what will be on. And most of the students, to be fair, everybody we've talked to after taking the MCATs generally does really well on the psych and social. That's the least offensive part of it. And we have 2 students who are currently at, we hope, right after Easter, that can come online with us who graduated from here and they're at Duquesne taking a year trying to get into Duquesne's new osteopathy school. I'm trying to get where that part is. Carry signal. Okay. 2 halves, for the most part, 2 hemispheres of the brain carry at the same time. However, the brain does exhibit some lateralization, primarily in one hemisphere or the other. The production and comprehension of language are localized to 2 areas of the left hemisphere. Emotional experience seems to be roughly divided between the 2 hemispheres, such that the left is more in positive emotion, where the right is more in negative emotions. I mean, I don't know if that's true or not. In general, right-sided, the way I would sort of characterize it, the left is probably less involved with emotions and the right more so. Remember, people who are right side dominant, artistic, creative, less that concrete organizational logic, math, language. I'm Mr. Right. I'm the most left side dominant person you're going to run into. My musical and artistic creativity, we know, would be registered on a scale from 1 to 100 as minus 52 and lower. So usually I write a note to my wife when I'm leaving, but I will get a text saying, "What the hell were you trying to tell me this morning?" Because even she can't read my handwriting after 20 years. So that's a little other nugget I was looking at in here. So I don't know whether to take that as gospel or not. But in general, I mean, if you're asked a question in any way that we can look at negative or more emotional response, but the ability for the frontal lobe, for everything to be filtered through this prefrontal cortex, it's just remarkable. That that really is. I like the way they explained it in one of the textbooks. It really is how our lives are enriched by emotions. Things that certain things we see or do. Every so often, I'll scroll through my phone and I'll see an image of my mom and dad, and I'll just go, with a big smile on my face. People I haven't seen in a long time. The basal ganglia, those are, we call them now nuclei because clusters of cell bodies within the central nervous system are nuclei, and And the way they phrased this was bringing the ganglia are like gangs of cell bodies outside, outside of the central nervous system, hence the term ganglia. I thought it was an easy way to remember it. And what happens there, okay, they are whatever the frontal lobe is saying in order to carry out that instruction, the basal nuclei are able to take that signal in such a way that makes it easy. And that's where their association with Parkinson's disease is. And what we call Parkinson's-like syndrome. They are basically motor. So we affect things typically motor-wise, whether we're speaking, whether I'm grabbing something. And again, the way when we see Parkinson's and Parkinson's-like syndrome, difficulty starting, stopping, irregular movements, herky-jerky kind of movements, all of those kinds of quote-unquote movement disorders, typically are things that we don't see in someone who's unaffected in those areas. It's the way all of us are. We're able to do this relatively effortlessly. Things like that. I could see in my granddaughter with her being, having a diagnosis of cerebral palsy, how that affects it, how it's very, very frustrating with certain things, not with others. So it doesn't matter what age, but you can see elements of it. Where all the occupational and physical therapy for her comes from. Effectively, this is where we start to deal with things, high order functioning, but to some extent not conscious. Thalamus and the hypothalamus. The hypothalamus is the link between the bloodstream, the link between your endocrine system, so things that are carried out in the bloodstream, endocrine, because that's where the blood-brain barrier is weakest. That's where all those wonderful sensors that we've talked about here. That's how where different levels of different hormones, charged particles, etc., glucose levels are all interpreted. That's the hypothalamus. And the thalamus is, even though it does a lot of processing on its own, what it principally does is it brings all signals, basically all sensory signals come through the thalamus. Some of them are processed there. A lot of them are directed then to the appropriate area, whether they have to go back to the cerebellum to be recorded for future reference, whether they have to go, and most of the time they're being directed. Remember that corona radiata, that white matter tract that goes from the thalamus and basically sends it. That comes from your toe, it's going here. Now you just heard that, that's going here. That's something you saw, that's going here. In effect, it pre-processes that information to a certain extent. So even though it's small, it's vital. And we see, and we understand that some of what our subconscious programming, so much so the thalamus will call something, oh, that's important, you better pay attention to it. Without us necessarily observing that. It's something, try to think of 1,000 issues. You'll be doing something and all of a sudden it reminds you, oh, I didn't do that. It's like, I knew I owed you guys a lab / lecture, and all of a sudden, oh, I didn't do that. Okay. You don't know necessarily what reminded you of it, all of a sudden it came to your mind when I'm watching the soccer match. So, thalamus, hypothalamus, the epithalamus, like I said, they're not including it, so I wouldn't. Really, it is considered more endocrine. That's the pineal gland, responsible for daily rhythms. And everything else here is stuff we don't control. Midbrain, neurotransmitters, particularly dopamine and norepinephrine, that are so what we call collectively, remember the name we give those are called catecholamines. They are almost always excitatory. And again, the dopamine is such an important one. That's that pathway that's involved in both Parkinson's and in addictive diseases. Dopamine pathways that are there. One goes to the basal, if you recall, there's a pathway to the limbic system from the midbrain called the meso, that's called the mesencephalon. Mesolimbic dopamine pathway. That's the one that's involved. I understand addictive diseases very, very well. I've done a lot of research into it, and I've taught a lot of courses involving addictive disease, and I have an A1 addictive personality. That's why I don't go to that place. I haven't been to that place down close to the stadium in a year. The green tables. Those machines that make a lot of noise. Because I like it. My dad said to me many, many years ago, Lou, there's a reason they keep building new, bigger, and better casinos. My mom had people one time oohing and eyeing. She had a crowd in Atlantic City around her. My dad, and she would go down there with friends or take bus trips, little old ladies in the Atlantic City days. And her birthday was November 11th. So 11/11/11 was 11/11/18 rather than 11/11/11. That really was something. And she played out on the roulette wheel and it hit. She probably had a chip on it. And so it's like 35-1. And oh, ma'am, you didn't take your winnings. No, let it ride. But ma'am, yeah, let it ride. Just whatever it was. She made, because the chip could have been, when you do roulette, you could pick the value of the chip, 50 cents, a dollar, a quarter. You have a certain minimum to bet. It hit again. And he starts, he goes, let it ride, Blues. Now, by that time, it was probably maybe about $100 worth of chips, and people had seen it hit twice, and the crowd got hit the third time. And the crowd was going nuts. Her mom was telling me, and then she collected her winnings. Because would you like us to rate you? That means they'll give you comps, complimentary stuff, and meals. And stuff. No, thank you. Okay. Little old lady walked off. I was sitting next to Blackjack at a $5 table. She won the first hand. Okay, she took the winnings and made another 5. She went 5 to 15. She won the second hand. All of a sudden, she put 50. She goes, hey, if you're winning, bet. Go, Ruth. She'd be a little old lady in Vegas, white gloves on, because you didn't have digital. It was all. So why do you have the white gloves? She goes, the quarters are dirty. No. So all of those kinds of things are part of it. That's mesolimbic, and you have another pathway from the midbrain called nigrostriatal. That's a pathway from the substantia nigra, one of the structures that goes to the corpus striatum, and that's the one that influences why we feel that dopamine plays a significant role in insufficient quantities in Parkinson's. Pons and medulla, we talk about that. We talked about it in respiratory and very cardiac control. Things that any damage in there is inevitably critical. And again, that's sort of the summary event for a lot of these structures that we're talking about. So, I mean, you can read through this. So me reading it to you, I don't think is as beneficial as us looking at it. So, I mean, I don't know if you're prepared or not, but we can talk about them and you can see what the book says. Well, I thought the questions were relatively straightforward, and we'll do that to conclude for my little discussion here. But some of those things I was talking about explained, I thought it gave me some clarity, like on how the charged particles moved, the distinction between how the nervous system works, being not truly an electrical system, though behaving like one. So these are the ones at the end. All right, we just did this. So you remember acetylcholinesterase. So let me just take a look at where these questions are located to make sure I give you the straight answers. And if there's something that we don't understand, that's not it. That ain't it, kid. That ain't it. Now I'm getting there. Okay. So acetylcholinesterase inhibitor. We did this. This is a test question. We're administered into a cholinergic synapse. Cholinergic, by definition, means one that produces acetylcholine. What would happen to the activity at the postsynaptic neuron? So if we have, what does acetylcholinesterase do? Pardon me? Yes, and if we inhibit it, it means the acetylcholine will be there longer. So if it's longer, what's it going to do? Is it going to, what happened to the activity? Typical question, would it decrease or increase? Do the same thing. If it's there longer, it's going to what? Pardon me? Be ears clogged. Yeah. Yeah, would it increase it or decrease it? Good. So, and why? So we got process of elimination, Stein's rule. We have two. We know it'll increase because acetylcholine will be produced more rapidly, or would it be degraded more slowly? Obviously, degraded more slowly. Proverbial slam dunk question. I love those. If I tell you once, I'll tell you 1,000 times. You're taught by a whole lot of people smarter than I am. I'm blessed with a great memory and I'm a test taker. I've been faking it for a long time. I can use big words. So my wife has a lovely way of expressing it to me. Stop bullshitting me. We have a wonderful romantic relationship. I love her and she puts up with me. White matter in the brain and spinal cord appears white because it's what? Contains what? Now, come on. Myelinated axons. Bang. Following is what is found in vertebrates but not in invertebrates. That's a basic biology question. That's zoology 101. What do vertebrates have? Pardon me? Dorsal hollow nerve cord. Bang, here we go. Got that taken care of. Okay. Which of the following activities is controlled by the cerebellum? Involuntary breathing, fine muscular movements of a dance routine, contraction of thigh, absorption of it certainly has nothing to do with microvilli in the intestine. Now, I just said to you, breathing is medulla and pons. We just had that in lecture. Okay, so we're down. And this is a reflex, process of elimination, motor memory. Dance routine kind of gives it away. That's what they did. Well, my daughter was doing all those figure skating routines. How do you know where you left off? When she fell, how did she pick it up right at the same point? Muscle memory just takes over. And so they do it when they miss these imperceptible things that you and I don't see in a Olympic level routine that judges see. And the men and women just do that remarkably well. If acetylcholine antagonists were administered generally, what would be effective? So it's something that blocks acetylcholine. Which part would be? So is it the effector? So remember, this is autonomic nervous system, sympathetic versus parasympathetic. The neuroeffector means the postganglionic nerve. So it produces what? Epinephrine and norepinephrine, right? So acetylcholine does that. Would be affected except. Wouldn't that be the except? Because the neuroeffector synapse in the parasympathetic is acetylcholine. The neuromuscular junction is acetylcholine. Acetylcholine's all over the effing place. The ganglionic synapse in the sympathetic, that's the preganglionic. So A is correct. Which of the following occurs as a result of a parasympathetic stimulation? Well, another one of those blood vessel test questions. I mean, that's coming on your test. Are blood vessels on the next test? Don't listen because you're taking this. Next time. Clog your ears. Which of the following occurs as a result of parasympathetic? The sympathetic is the one that does anything with the arteries. Got that? Increasing the rate. So if we occurs as a result of parasympathetic, acetylcholine, what does it do to the heart? Slows it down. Does it cause erection of the hair and skin? Does it cause contraction of the abdominal muscles? Which of the following is going to be the result of that particular thing? What would you guess? So, 38. Parasympathetic stimulation results in rest and digest responses, which occurs as the following as a result of parasympathetic stimulation. So, vasodilation of the arteries leading to the kidneys. See, they gave you that answer. I think it's a poorly worded question. Parasympathetic has nothing to do with this. It certainly doesn't do that. Exercise, they don't. Oh, okay. This is kind of a trick question that's there. The kidneys are not under the impact. That's a poor question of that. So they answered A. Choice B is sympathetic, as is choice C. Choice D is mediated by skeletal muscles. Okay, abdominal muscles. They're talking about skeletal muscles. I'm thinking about the smooth muscles in the alimentary canal. So that's a bad question because it's misleading. The arteries in the kidney are under sympathetic stimulation, not parasympathetic. They're not. Get with the program. Reflex. Okay. Reflex arts involve motor neurons exiting the spinal cord dorsally. Those are sensory nerves. Require fine control by cerebral cortex, not in the least. Reflexes are protective, they're automatic. Always occur independently. Anything that says always, I get excited about. Okay? I mean, when you say always occur independently, someone's going to do a knee-jerk test, you can control it. Okay, often involve inhibition as well as excitation of muscle groups. Probably the best answer. Which of the following structure is not part of the central nervous system? We just went over that. So a parasympathetic effector, medulla, hypothalamus. If it's not up on the list, it doesn't belong. The one we had up there before. I know we're out of time. I can't do the last ones. All right. I will send you the answers anyway. So I'll find out.